Hello friends, welcome to SS Academy. Today we are going to explain about chemical reaction in 10th class chemistry. So our topic is how do we know that a chemical reaction has taken place? And this can also be asked in different way, what changes takes place during a chemical reaction. So let us going to explain it by using three activities.
Okay, well friends, here in this activity we have to done few things and we have to observe few things. So in the first step we have to take 1 gram of quicklime. 1 gram of quicklime. You know that the formula for quicklime is CaO, calcium oxide. And to this we have to add 10 ml of water. To this we have to add 10 ml of water. So here 1 gram of quicklime is taken in a beaker. You have to take it in a small beaker. This is a beaker. First you have to take small amount of quicklime, and to this you have to add 10 ml of water. So second step what you have to done is, after the reaction is completed, then you have to touch the, after some time, touch the bottom of the beaker. So these are the two things we have to done. So now the things we need to observe is, when 1 gram of quicklime is added by 10 ml of water in a beaker, you will observe that a colorless solution is observed. A colorless solution is observed. A colorless solution is formed. So when you touch the bottom of the beaker, so you will find it is hot. You will find that it is hot. So so previously it was not hot, but when you add quicklime with the 10 ml of water, so after the completion of first step you will observe that the beaker was hot. So from this we can conclude that this some amount of some amount of heat energy is released. Some amount of heat energy is released. Therefore this reaction is an exothermic reaction. What kind of reaction it is? Exothermic reaction. So that means energy is liberated, heat energy is liberated when reaction is completed. So it does not happen for every reaction. For few reaction it is one of the identification. Heat energy may be released, so we can write heat energy may be liberated when reaction is completed. So this is the activity one. Now let us move on to the second one. So the first step is, so here what you need to do is, so take 100 ml of water in a beaker. So what you need to do, you have to take 100 ml of water in a beaker. To this you have to add small quantity of sodium sulfate. So what is it? Sodium sulfate. Got it. So this is the first step you have to done. In the second step, do the same thing. Take 100 ml of water and in a beaker, 100 ml of water in a beaker, and add small quantity small quantity of barium chloride. And third step, before going to the third step, we have to go to the things to be observed section. So when 100 ml of water is added to the small quantity of sodium sulfate, you will find that a colorless solution, a colorless solution of sodium sulfate, colorless solution of sodium sulfate is formed. Same another here in this case also, when 100 ml of water is added to a small quantity of barium chloride in a beaker, you will find that a colorless solution is formed. Here also a colorless solution of barium chloride is formed. So consider this is solution 1. Consider this is solution 1 and consider this is solution 2. So in the third step, what you need to do, mix these two solutions. Mix the above two solutions. So here this is a very important step, so where you need to observe few things. So here you know that both the solutions are colorless. Barium chloride solution is colorless and sodium sulfate solution is also colorless. So when you start adding sodium sulfate solution to barium chloride solution, so here when this solution comes in contact with the barium chloride solution, when sodium sulfate solution comes in contact with barium chloride solution, at this contact point you will find that a white colored substance is formed. A white colored substance is started to form. So that means what is happening here? A white colored insoluble substance. Insoluble substance is formed. So this is the thing we have to observe. We observe here. So what is this white colored substance? How do you say that this is insoluble? So as soon as the white colored substance is formed, it immediately settles to the bottom. It goes to the bottom and it settles at the bottom. So as it was insoluble, that's the reason it is going to the bottom and it is settled down to the bottom. So the thing which formed in a reaction and which is insoluble, that is called as a precipitate. That's what you call a precipitate. So here a precipitate is formed. What is formed here? A precipitate is formed. So things to be note that a precipitate may be formed during a chemical change or chemical reaction. During a chemical change or chemical reaction. So this is the activity. So now let us see activity number 3. So here we know that we have two columns here, things to be done and things to be observed. So here we have to perform, the first step is we have to take few zinc granules in a conical flask. So take some zinc granules in a conical flask, and to this you have to add 5 ml of dilute hydrochloric acid slowly. So we have taken zinc granules in a conical flask and to this added 5 ml of dilute hydrochloric acid. Okay, so then after that you have to keep a burning matchstick at the opening of the conical flask. at the opening of the conical flask. So, and in the third step we have to do is touch the bottom of conical flask with your fingers. These are the three steps you have to done, and then you have to observe. After every step is completed, you have to observe what was happening in the conical flask. So here, when few zinc granules in a conical flask are added by 5 ml of dilute hydrochloric acid, you will find that some colorless gas is evolving. So you observe that a colorless gas is evolved. A colorless gas is evolved. So you will find some vapors. When you heat water, you will find that some kind of this kind of some colorless gas is evolved from the conical flask. So that is the first observation. And what is the second step here? Keep a burning matchstick at the opening or mouth of the conical flask. When you keep a burning matchstick here, so that means this matchstick, the burning matchstick is exposed to this gas which is evolved from the conical flask. So here, so when this gas comes in contact with the flame, when this gas comes in contact with the flame, the gas burns with pop sound. The gas burns with pop sound for some time, and it will be put off, later. So here, when the burning matchstick is exposed to the gas evolving from the conical flask, this gas burns with pop sounds. That means while it is burning, it makes some pop sounds. So after some time it will be put off, that flame will be put off. So you know that whenever a gas burns with pop sound and it was put off later, that gas is confirmed as hydrogen gas. The gas which is liberated or evolved there is hydrogen gas. That means in this reaction, so some hydrogen gas is liberated when zinc granules is added by dilute hydrochloric acid. What is the third step here? Touch the bottom of the conical flask with your fingers. When you touch the bottom of the conical flask here, you will find it is hot. So it was hot when you touch the bottom of the conical flask. That means this reaction is an exothermic reaction. An exothermic reaction since heat is liberated. So here the thing you have to be noted, you should note this point here. So what he liberated here? A colorless gas is evolved. So gas may be evolved. Gas may be evolved during chemical change or chemical reaction. Okay, from all the three activities, we can conclude that in every activity we will find that a new substance is found. In the first activity, a colorless solution is formed. So you know that its physical state is changed and a color is also changed in the first activity. In the second activity, you have observed a white colored precipitate. So here also physical state and color is changed and a new substance is formed. In the third state also, if you see, a gas is formed. That means a new substance with a different physical state and color are formed. So that means you can conclude that during a chemical change, new substances will be formed. That means new products will be formed with a different physical state and color, different color. Sometimes it may happen, sometimes it may not be happen. And the second one is, you observe that in the first and third activity, heat was liberated. You will find the beaker and conical flasks are hot. That means heat may be liberated in a chemical change. And in the second activity we got some precipitate, a white colored precipitate. That means precipitate may be formed during a chemical change. So gas may be evolved. In the last activity we have obtained a gas. Some gas is evolved. That means gas may be evolved during a chemical change or chemical reaction. So a small point. So you know that an element, atom of an element is represented by symbol. Molecule of element or compound. Molecule of element or compound is represented by formula. And you know, we are using, every time we are using chemical reaction. So a chemical change is represented by chemical reaction. Chemical change is represented by chemical reaction. For example, oxygen, the first one example, oxygen atom is represented by oxygen, symbol O. And nitrogen molecule is represented by a formula using N2. Similarly, chemical reaction. So if you take calcium oxide, when added by some amount of water, it produces a colorless solution. So this chemical change, is represented by this chemical reaction, like that. So an atom is represented by symbol, a molecule is represented by formula, and a chemical change is represented by chemical reaction. So that's all friends. Thanks for watching my video. If you like this video, please like and subscribe to my channel. Thanks for watching SS Academy. Thank you.